Chapter 3, Section 3, Function Notation. You guys heard of function notation before? Some of us yes, some of us no. Pretty easy, those of us that know about it? Good. Uh-oh. Well, let's go over it. Good thing we're going over it again. So, last chapter, or last section, 3.2, we talked about linear functions, correct? How do I know if a function is linear based on its equation? If I can write it in the form y equals mx plus b. So that's what that first sentence says. You know that a linear function can be written in the form y equals mx plus b. We all remember that. Okay? By naming a linear function f, you can also write the function using function notation. So this is function notation right here. Okay? Looks very similar to y equals mx plus b, correct? Yeah. So we do not read that as f times x or fx. We read it as f of x. Everyone say it after me. F of x. 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 So this is f of x equals mx plus b. It's a function of x. That's why we say f of x. Okay? So the notation, f of x, is just another name for y. We don't treat f of x any different from y. It just looks different. So that shouldn't be too bad, correct? Okay. F of x is just another name for y. If f is a function and x is in its domain, then f of x represents the output of f corresponding to the input x. So this is what that means. Usually, how do we write an ordered pair? What, comma, what?
X, comma, y.
X, comma, y, correct? Now we're dealing with function notation, f of x. So my ordered pairs are going to be x, comma, what? What do we treat like y? F of x. That's what my ordered pairs are going to be like. We treat f of x like y. So it really doesn't change anything. But that's what that second part of that bottom paragraph is saying. If f is a function and x is in its domain, then f of x represents my output values. That's what it's saying. My y values are my outputs, correct? So we write it as x comma f of x. Any questions on that?
No, sir.
Last part of this, you can use letters other than f to name a function, such as g or h. So we could say g of x, or we could have h of x. We could see g of t, h of s. We could see all sorts of letters in there. Okay? Everyone knows how to say it, though.
Yep.
Say it again.
F of x.
F of x. Very good. Any questions so far about function notation? Can I move on? Okay. Example 1. Evaluate f of x equals negative 4x plus 7 when x equals 2 and x equals negative 2. So we're used to seeing this written as y equals negative 4x plus 7, correct? But we're just treating f of x like y. So if I gave you this equation, and I told you to evaluate that when x equals 2 and x equals negative 2, what would you guys do with that? Plug what in where? Be a little more specific for me.
So you would do it one at a time, x2 into negative 4x plus 7, and then
Wait, say it again.
plug 2 into negative 4x plus 7, and then negative 2 is negative 4 plus 7.
So plugging 2 and negative 2 into which variable?
X.
X, very good. Because that's what it's telling me x equals, correct? No difference with function notation. Still the same concept. Still plugging these values in and getting our y values or our f of x values in this case. Okay? So anywhere in my function notation, anywhere I see an x,
You plug in 2.
anywhere I see an x, I replace it with 2. And I'm going to do it again. And anywhere I see an x, I replace it with negative 2. So I'm finding f of 2. I'm finding my value of f of x when x equals 2. So everyone see that? So f of 2. Now we follow our order of operations. Which comes first, multiplication or addition? Multiplication. It's negative 4 times 2. Negative 8. Negative 8 plus 7. Negative 1. So the value of f of x when x equals 2 is negative 1. Questions on that? Not too bad? Now I've got to do it again though for negative 2. So now I'm finding f of negative 2. Replace all my x's with negative 2. We said multiplication comes first, so what's negative 4 times negative 2? 8. Positive 8. 8 plus 7? 15. So the value of f of x is 15 when x equals negative 2. Pretty easy?
So the f of x doesn't mess with the equation at all?
Nope. We just treat it like y. So f of x is being treated as one variable. We don't treat it as two separate variables. Okay, even though it's two letters, it's f of x, the function at x. Okay? Questions on example 1? Example 2. Here we have f of t instead of f of x. It says let f of t be the outside temperature in degrees Fahrenheit t hours after 6 a.m. Explain the meaning of each statement. So f of t, or my y in this case, is the outside temperature in degrees Fahrenheit. My t, or my x, was what we're used to dealing with, is my number of hours after 6 a.m. Everyone okay with that? Yep. Okay, it gives me 3 statements down here. And wants me to explain the meaning of each statement. So letter A, I have f of 0 equals 58. F of 0 equals 58. So what does t represent again?
Hours after 6 a.m.
Number of hours after 6 a.m. What did they plug in for t here on letter A? 0. So what do you think 0 means in this case?
0 hours after 6 a.m.
0 hours after 6 a.m. So what time are they talking about? 6 a.m., right? 0 hours after 6 a.m. is 6 a.m. So what is this statement saying on letter A?
At 6 a.m. it was 58 degrees.
Very good. The temperature was 58 degrees Fahrenheit at 6 a.m. Does that make sense for letter A? Because f of t represents the temperature outside, so f of t, well, f of 0 equals 58, so that's the temperature outside. T represents the number of hours after 6 a.m., so 0 would be 0 hours after 6 a.m., so that's at 6 a.m. Questions on part A? Does that make sense?
Yes.
Okay, part B. Raise your hand if you can help me out on part B.
6 hours after 6 a.m.?
So T represents the number of hours after 6 a.m., so we're talking about 6 hours after 6 a.m.
So 12?
So 12 o'clock p.m., right? What about 12 o'clock p.m.?
It was 1?
No? What does it say? What does it equal? N. So, temperature was in degrees Fahrenheit at 6 hours after 6 a.m. So it's 6 hours after 6 a.m.? 12 p.m. Questions on B? It was in degrees Fahrenheit outside at 12 p.m. Letter C. F of 3 is less than F of 9. F of 3 is less than F of 9. Anyone raise your hand and help me out?
The temperature at 9 a.m. was less than the temperature at p.m.?
Not 2 p.m.
1 p.m.?
3 p.m. Very good. So, f of 3 is representing the temperature 3 hours after 6 a.m. So 9 a.m., right? F of 9 is representing the temperature 9 hours after 6 a.m. So that'd be 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3. 3 p.m., right? So it's saying the temperature at 9 a.m. was less than the temperature at 3 p.m. Does that make sense for letter C?
Yep.
Any questions on that? We good at interpreting function notation?
Yes.
Wait, so with this type of problem, it would be fine to just put in as a Fahrenheit?
On letter B?
Yes.
Yeah, because that's what it's telling me, right?
Yeah.
The temperature outside 6 hours after 6 a.m. was in degrees Fahrenheit. That's all I got to put for B. Other questions? Can I move on?
Yes.
All right. We good so far?
Indeed.
Pretty easy? Okay.
All right.
Okay, example 3. For h of x equals 2/3 x minus 5, find the value of x for which h of x equals negative 7. Any ideas what to do here? Can anyone help me out? Raise your hand. Do what? For what? For h of x, right? Previously, on my previous slides, it said to evaluate the function f of x when x equals 2 and x equals negative 2. Is it asking the same thing here? No, it says now find the value of x when h of x equals negative 7. So like we said right here, I'm replacing h of x with negative 7, and then what am I solving for? X. Finding the value of x when h of x is negative 7. We good there? So negative 7 equals 2/3 x minus 5, and now I just have an equation that I'm solving for x. Everyone see how I've done that? So what's my first step to get x by itself?
Add 5 to negative 7.
Add 5 to both sides. Negative 7 plus 5. Negative 2. Raise your hand if you can tell me my last step to get x by itself.
Divide 2/3.
Very good. Divide both sides by 2/3. So what do I get for x when I do negative 2 divided by 2/3?
Negative 3.
Negative 3. So the value of x when h of x equals negative 7 is negative 3. So how would I write this ordered pair if you wanted me to write this ordered pair? What's my x value?
Negative 3.
Negative 3. What's my h of x value?
Negative 7.
Negative 7. Everyone understand how to interpret that? Okay. Questions on example 3? Can I move on? All right. We're just flying through this, aren't we?
Indeed.
Good stuff. Oh, now we got a graph in function notation.
Actually, that's not useless.
If I gave you y equals 2x plus 5, what would be y'all's first thought on how to graph this?
2 would be x.
Nope.
What? 1 would be 2.
Nope.
5?
Could we create a table of values?
Yes. Could.
I could pick x values to plug in and I'd get y values out of it. So I might possibly pick negative 2, negative 1, 0, 1, and 2. Right? Same concept, except instead of having an xy column, I'm going to have an x column and a what column?
X.
F of x. We don't say fx, do we? How do we say it? F of x. Very good. So I want to pick the same values. And I'm just plugging these into my function. So, f of negative 2 equals 2 times negative 2 plus 5. What's 2 times negative 2? Negative 4. What's negative 4 plus 5? 1. Everyone okay getting your f of x values after plugging in an x value? Okay, plugging in negative 1. What's 2 times negative 1?
Negative 2.
Negative 2 plus 5.
7. 3.
3. Very good. Everyone with me?
Yep.
Negative 2, or positive 2 times 0.
0.
0 plus 5.
5.
5. Plug in 1. 2 times 1.
2.
2. 2 plus 5.
7.
Now it's 7. And plug in 2. 2 times 2.
4.
4. 4 plus 5.
9.
Questions on how I've plugged in? How I got my table of values? We good? Now I just have some ordered pairs that I can graph. Right? So it was negative 2, 1, negative 1, 3, 0, 5, 1, 7, 2, 9. So graphing ordered pairs, let's quick refresher on that. For my first ordered pair, it's negative 2, comma 1. Which two directions am I going and how many units?
To the or
Left 2,
Yeah,
Down 1.
up 1. Very good. Left 2, up 1. Put a point. Everyone okay graphing ordered pairs? Okay, negative 1, comma 3. Which two directions am I going and how many units? Left 1, up 3. If my x value is negative, I go left. If my x value is positive, I go right. If my y value is positive, I go up. My y value is negative, I go down. Right? I mean, correct? 0, comma 5. Which two directions and how many units? I'm not going left or right any, am I? I'm just going up 5. 1, comma 7. Which two directions? Right 1, up 7. Everyone good? And then 2, comma 9. Right 2, up 9. This will just keep going on forever and ever, correct? I just picked 5 points on the line to plug in to get my line. That will keep going on forever and ever.
Does it have to be 5?
I'd like you to do about 5 points, yep. Goes on forever and ever and ever, both directions. Okay? And there's my graph.
We can just pick any
Yep. I mean, you probably want to pick values that are going to help you. Right? If there's not really a fraction in front of x, I usually like to pick the same values, negative 2, negative 1, 0, 1, 2. Now, if there's a fraction in front of x, I like to do multiples of my denominator, so my denominator will cancel, and I'm not graphing fractions, if that makes sense. Okay? And you usually want to get numbers that are actually on the graph that you're given. So if you plug in negative 2, and it gave me like 15 when I plugged it in, I probably want to pick some different values. Okay? Questions on example 4? You okay graphing? Now later in this chapter, we'll learn a new way to graph, which you guys have hopefully probably seen before, using our slope and our y-intercept. But for right now, we're just going to use the table of values. Okay? Any questions, comments, concerns?
No.
Here's our assignment. Page 127. Numbers 1 through 27. Odds. Changed it up on you. It's odds instead of evens. Huh?
Why are you done?
What do you mean, what have I done? So we do... Golly, I can't write. So we do Thursday, the 28th, on Canvas. Okay. Are there any questions, comments, concerns before I end my recording?
No, there's not.
Okay.